Hello everyone. So in this video, I'll be discussing 2022 past year of MME, and this is a part of NEP only. So I'll tell you for the first question, it is of 2 into 6. This is 12. Before this, the 2023 part past year I have already solved and I have already uploaded it. Okay. The second question, 20. So 20, the first was of 12. So we have 32. This is 3 into 4. This is 12. 32 plus 12, 44. This is also, you are supposed to attempt 3 only. 44 plus 12, 56. The fifth question is 3 into 6 marks. 18. 56 plus 18 gives you 74. The last question. So this you are supposed to answer any 2. Okay, so 8 into 2, which is 16. So 74 plus 16, 90. So the total paper is of 90 marks. And this is as per your NEP. And I'm telling you again that 2023 past year has already been solved. And it is being uploaded on the channel as well. Okay. Now, starting with the first question. First part, find all the values of x satisfying this. So this would be satisfied when this is positive, this is negative, or this is negative, this is positive. So suppose we take this as case 1. So if you are talking about case 1, mod x minus 2 should be positive and x plus 5 should be negative. So mod x should be greater than 2 and x should be less than minus 5. So the domain for this would be minus infinity to minus 5. This is an open bracket. Whereas for this, it would be minus infinity to minus 2 union 2 to infinity and then intersection with the second condition. So this is positive, this is negative. Okay, so you will see the intersection would give you this thing, minus infinity to minus 5. You can draw this on a number line as well. So minus infinity, minus 5, minus 2, 0, 2, infinity. So what we are having is this portion. This is from case 1. Now suppose we are discussing case 2. Let this be case, this was case 1, this case 2. So mod x minus 2 is less than 0 and x plus 5 is greater than 0. So mod x less than 2 and x greater than minus 5. So x would lie between minus 2 to 2. We will have minus 2, x 2, and x would lie between minus 5 to infinity. So drawing this on the number line again, you will see the intersection from minus 5 to infinity and minus 2 to 2 will give you minus 2 to 2 only. So now this is what we have got from case 1 and this is what we have got from case. So this is what we have got from case 2. This is what we have got from case 1. So all the values of x would be minus infinity to minus 5 union minus 2 to 2. So for all values of x lying in this equation would be satisfied. Okay, now moving to the second question. If a and b, okay, if a and b are two sets containing 4 and n elements respectively. So it is given n of a equals to 4, n of b equals to 7. Find the maximum and minimum number of elements in A union B. So you can draw this with the help of a Venn diagram. So if you want to find the maximum, they should have nothing in common. That is, they should be disjoint sets. So this is B since it has more elements. So A intersection B should be 0 if we want to find the maximum elements of A union B. So in this case, B has 7, A has 4. So the total elements become, which is equals to 11. And minimum would occur when A is a subset of B. And in this case, A union B would be equal to 7. And A intersection B similarly is 4 in this case. You are not supposed to find this, but they can ask you this type of question. Okay. So moving on to the next part. Fill in the blank with necessary, sufficient, or necessary and sufficient. If A is sufficient condition for B, then not B is dash condition for A. So if we know that if A is sufficient for B, then B is necessary for A. And similarly, not B would be sufficient for A, sufficient for not A. Okay. For the second part, for a rectangle to be considered a square, having 4 sides of equal length is, so if we have a rectangle, and if we want to consider it as a square, so all the 4 sides should be equal length. So it is a necessary and sufficient condition both. Okay, x greater than 0 is, so if x is greater than 0, this is positive and this is also positive. So this is satisfied. So it is sufficient for sure. We are not sure about necessary or not. But if, so look at this thing. If this is negative and this is negative, then the whole term would be positive, right? So x into x plus 4 can be negative. When x is negative, x plus 4 is negative. So this would be greater than 0. So this means x takes value minus infinity to 0 open. And with the help of this, x plus 4 should be less than 0. X should be less than minus 4. So x would take the value minus infinity to minus 4. So with the intersection of this, the range would be minus infinity to, the domain would be minus infinity to minus 4. So if x lies between this, in this range, this equation would still be satisfied. So this is not a necessary condition, but this is sufficient to make sure that this condition is satisfied. Okay. Now moving to the next part. For two sets x and y, x union y equals to x. X union y would be equals to x when y is a subset of x. So this would be both sufficient and necessary and sufficient condition. So this would be both necessary and sufficient condition. Okay. Now I'll just erase this. Okay. Now looking at the next C part, we are supposed to draw the graph of x square minus x minus 6. Mod of. So mod of this. So fx is x square minus x minus 6 if x square minus x minus 6 is greater than equal to 0. And this can be written as x square minus 3x plus 2x minus 6. Taking x common, minus 3 plus 2 times x minus 3 should be greater than equal to 0. So we have x plus 2 into x minus 3 should be greater than equal to 0. Then the function would be written as this. So this is possible. Okay. So x plus 2, x minus 3 should be greater than equal to 0. So this is possible when both of them are positive or both of them are negative. For negative multiplied by negative would give you a positive thing. So x plus 2, suppose we take the first case, is greater than equal to 0 and x minus 3 is greater than equal to 0. This means x should be greater than equal to minus 2 and x should be greater than equal to 3. So the interval is minus 2 to infinity, intersection 3 to infinity. So look at this. These are closed intervals because it is less than greater than equal to. So the intersection of this would be 3 to infinity. So this is with the help of when both of them are positive. Now let us take the case when both of them are negative. Okay, looking for space. Okay, suppose x plus 2, x minus 3 less than 0, less than 0. So x plus 2 is less than 0, which means x is less than equal to minus 2 and x minus 3 is less than equal to 0, so x should be less than equal to 3. So the interval would be minus infinity to minus 2, intersection minus infinity to 3. So all are included in this case. Okay, I'll write it here. Okay, so with the help of this we have 3 comma infinity, and with the help of this, if we'll solve it, the intersection would be minus infinity to minus 2. So the function would take value this positive term when x belongs in the interval this union, this is closed, 3 comma infinity, and fx would be equals to minus of x square minus x minus 6 when x belongs to minus 2 to 3. So this is the remaining. Okay, so look at this line, number line. This is minus infinity, suppose, then minus 2, 3, infinity. Okay, infinity here. The function takes value this in the red when x lies in this, including, and the function would take value this when x lies here. Okay, so far we have got the function, right? Okay, now you can see this is a polynomial with degree 2. Okay, you just need to plot this. So when x is minus 2, okay, when x is minus 2, this would be 0. When x is minus 2, this is 0, y equals to 0, and when x is 3, y is 0. Okay, so we have when x is 3, y is 0, and when x is minus 2, y is 0. Okay, now you can see where the vertex would be or the maximum point would be. So you must know this formula, minus b by 2a, and the maximum value would be c minus b square by 4a. So minus b by 2a would give minus 1 minus of minus 1 upon 2, and c minus b square would be minus 6 minus b square is minus 1 square upon 4. So this would be half, it would be minus 6 minus 1 by 4, this is minus 25 by 4. So at half the value is minus 25 by 4. So when x is half, value is minus 25 by 4. Okay, so we will have a curve like this, but this is just this particular value, not the value of this. Now since we have found this, and fx was minus of x square minus x minus 6 for x belonging to the interval minus 2 comma 3. So it is nothing but minus of this. So it would be a mirror image like only. Okay, so it would be somewhat like this. But since this is a mod, so y would take positive values only. So a function would be in yellow. So this is taking positive value. Then and you can mark these points. You should mark these points. So this was when x is minus 2, y 0. This is when x is 3, y 0. And this is the point that we have found the maximum or the minimum value. So this was half comma minus 25 by 4. You can find this point as well, because at this point the graph is this and the value of x is 0. So this would be minus of 0 minus 0 minus 6. So this is 6. So this would be 0 comma 6. So the one in the yellow is your final graph. Okay. Now moving forward. Okay, so this is for PWD candidates because there might be some problem for them to draw the graphs. Okay. Find the demand equation for the product assuming that it is linear. Suppose the consumer of a product demands 60 units of a product when the price is rupees 5 per unit. So when price is 5, he is demanding quantity 60. And 40 units when the price per unit has gone up by 4. Gone up by. So the new price is 9 and the quantity is 40. You find the demand equation when assuming that it is linear. So when it is linear, we have p minus y minus y naught. You know this formula equals to slope times x minus x naught. M times. ठीक है. Y minus y naught is m times x minus x naught, where m is slope. So this would be, the slope is change in y by change in x, and on the y axis we have price and quantity on the x axis. So change in y would be change in price, so which is 9 minus 5. Change in quantity would be 40 minus 60, and quantity is q minus 60 original. So this would be p minus 5 equals to 4 upon minus 20 q minus 60 minus 5p plus 25 equals to q minus 60. Q equals to minus 5p plus 85. So this is the demand function that you are getting. Express total revenue as a function of price. So you have quantity and we know total revenue equals to price into quantity. So this would be p into minus 5p plus 85. This would be minus 5p square plus 85p. So this would be total revenue as a function of price. Okay. And find the price for which total revenue is maximum. So you know total revenue would be maximum for the price when price is this, and the maximum value would be c minus b square by 4a. We have already found this. Okay, we have already solved for some other thing. Okay, so the price would be minus b is 85, 2a is 2 times minus 5. So minus minus cancels out. So this is coming out to be 8.5. Because 85 upon 10 is 8.5. So the price is 8.5 at which the total revenue is maximized. Okay. Now for the second question, the weightage is 5. So you're supposed to attempt any 4 and every question carries 5 marks weightage, so it would be 20. Okay, the value of a new car decreases after it is purchased according to an exponential decay model. Suppose that the value of the car is 12,000 at the end of 5 years. So suppose initially the value was something X. After 5 years, with the taking into consideration the exponential decay model, it has become 12,000 after 5 years. And that its value has been decreasing at the rate of 9% per year. Okay. So we know the depreciation rate is 9% per year. So we have value, current value in the time period T is the original value and then the discount factor. That is, this takes into consideration the depreciation rate as well. Okay, so in this case, since the value is falling by 9%, so A would be 0.91. So initially if it is X in the next year, it would be 0.91 into X. And then next year 0.91 into 91 square into X. Okay, so A is 0.91 and we get A as 1 minus 9 by 100. So this is 91 by 100, which is 0.91. Okay. So we know, and the current value it is given to us that it is 12,000 after 5 years. So we have 12,000 equals to V naught. This is the original value of the car when it was bought, and 0.91 to the power 5. So you are supposed to find the value of the car when it was new. So V naught, we can solve it. It would be 12,000 upon 0.91 to the power 5. And the use of simple calculator is allowed. So you can find the value of this. Now we are supposed to find T when the value of the car reduces to half of its value when it was new. So the original new value was V naught, and what they are asking is that we are supposed to find a time period T star such that, so at time period T star the value would be V naught and it would be depreciated by T star times. So this should be equals to half of V naught. Okay, I'll write it here. So what they're saying is T star should be equals to V. So after T star years, the value would have depreciated to this thing, and this should be equals to half of the original value. So V naught would cancel out. You will take log on both sides. So T star log A should be equals to log half, and A we already know it is 0. So T star would be log half upon log A, and log A was 0. A was 0.91. So this would be the value of T star at which the value of the car would reduce to half. So after this much years, the value of the car would reduce to half of the value that it originally had. Okay. Now moving to the next question. A country exports 3 goods: wheat, coal, and palm oil. At time T equals to T naught, the revenue in crores of rupee derived from each of these goods is WT naught equals to 4, CT naught equals to 10, and OT naught equals to 7. W is declining at 3%, while O and C are growing at 15 and 8% respectively. Find the rate of growth of total export earnings. So basically export consists of 3 components, in this case wheat, coal plus palm oil. Now growth rate is given to you and the initial values are given to you. So if you'll do a log transformation, you'll have log C. And now if you differentiate this with respect to time, the export earnings, so this would be 1 upon W naught plus C naught plus O naught into W dash T naught plus C dash T naught plus O dash T naught. Okay, so I'll write it here. So this would give us the total growth rate, because the exports consist of three sectors, and then with the help of weighted average of the growth rate of these three sectors, we can find the total growth of, so we can find the rate of growth of total export. Okay, so this would be W naught was 4, C naught was 10, O naught was 7. So 4 plus 10, 14 plus 7, 21. So we have 1 by 21 into W dash T naught. So W is declining by, so what we have here is W is declining by 3%. So minus 0.03 into W naught plus, so okay, at time T naught, the revenue in crores of rupees derived from each of this good is, so in the next year, if it is decreasing by 3%, it would become 4 into 0.97. So it is decreasing by 3%, and the initial value of what the revenue from the wheat was, and then CT is 10 and C is increasing by 8. Okay, so it would be 0.08 into 10 C naught plus, then this is increasing by 15%, 0.15 into O naught. So you need to substitute these values, 1 by 21 into minus 0.03, W naught is 4 plus 0.08 into C naught is 10 plus 0.15 into 7. Well, so the value is 1 by 21 minus 0.12 plus 0.8 plus 0.15 into 7 is 1.05. I'll just cross verify it. 0.8. You need to be very careful with the decimals. So the final value that you will get is minus 0.12. So this is coming out to be 1.73 upon 21. So 1.73 upon 21 is 0.082. So the rate of growth of total export earnings at T naught would be 8.2%. Okay, now moving to the next question. Next part of the second question. Find the inverse demand curve. Examine the so this is the inverse demand curve only. So when P is written, when the quantity demanded is written as a function of P, it's an inverse demand curve. Show that the demand increases from 0 to indefinitely large amounts as price falls. Okay, so x plus 1 into P can be written as 20, x plus 1 20 by P, x equals to 20 by P minus 1. So this is our demand function. Show that the demand increases from 0 to indefinitely large amount as price falls. So you can observe when price is 20, demand would be 0. And if price is anyway above 20, so x is coming out to be negative, which means x is 0 only. So for any price greater than equal to 20, the quantity demanded is 0. So we are supposed to show that the demand increases from 0 to indefinitely large amounts as price falls. Now we have shown this at price 20 or any price above 20, the demand is 0. And if price falls, now suppose price limit x as p approaches 0. So this would be limit 20 upon p minus 1 as p approaches 0. So this term would approach infinity. So as the price level falls, the demand would approach infinity. So we have shown this. Okay. Now, okay, we had x equals to 20 by p minus 1. Find total revenue and show that it increases to a limiting value. So total revenue is price into quantity. So p is 20 upon x plus 1. P into x would be, so we have 20x upon x plus 1. Taking x common, and limit as x approaches infinity. So the total revenue, okay, so the total revenue is, can be written as this. And when limit x approaches infinity, this term would approach 0, and this, so the total revenue would have a limiting value of 20. Okay, now moving to the next part. So consider an infinite series summation ai. Prove that limit an equals to 0 is necessary for convergence for the series but not sufficient. Okay. So suppose the series would be a1 plus a2 till an, and as n approaches infinity, so an. So if this term is converging, then the rest of the terms would also converge. So if you're talking about the sum of the series, if you are including this term as well and the series is converging. So I'll give you an example. Suppose limit sum of n as n approaches infinity is coming out to be s. Okay, so this is a fixed number, and limit Sn minus 1 where an is not considered, and as n approaches infinity, this is also coming out to be s. Then an can be written as, so the first series is a1 plus a2 plus till an. Sn minus 1 is a1 plus a2 till an minus 1. So an can be written as s of n minus s of n minus 1. Okay, now if an is converging to 0, so this would ensure that the rest of the terms are also converging. So limit would converge to 0. Now, but this is not a sufficient condition, because if you will see the series, 1 by n, I equals to 1 to n. So limit infinity. Limit as n approaches infinity, this would be close to 0. So although the nth, this term is 0, but the sum of the series would not converge, because the sum of this series doesn't converge. Okay, so this can be example to this is an example to show that this is not a sufficient condition. So if the okay, So we'll move on to the next question. Okay, moving to E part. If fx equals to x to the power n e to the power x, show that fx decreases for this. So you know, to show off whether function increases or decreases, you can have the first order derivative. So the first order derivative is derivative of first function n into x into n minus 1 into e to the power x u dash v, using the quotient rule, u dash v minus v dash u square, right? So this is nothing but, you can take ex common and x to the power n minus 1 common as well. So you are left with n minus x upon ex whole square. So ex cancels out. So we are left with x to the power n minus 1 ex n minus x. So this is f dash x. So we are supposed to show that fx decreases for x greater than equal to n. So if x is greater than n, equal to n, this term would be less than equal to 0. And since this term is positive, this term is positive, so f dash x would be less than 0 for x strictly greater than equal to n. Okay, now and find the local maximum value of fx. So we know that suppose whatever the function is, it is always decreasing, and f dash x would be equal to 0 when n equals to x, and after this it is strictly falling. So at n equals to x, we will have the local maxima. You can find the local maximum value. You just put, it would be x equals to n, it would be n to the power n e to the power n. So this is the local maximum value. Now, and you need to show that the f double dash x is less than 0 as well. So the second order condition, you are supposed to show this as well. Now find f of 2x. F of x, we have f of 2x would be 2x to the power n upon e to the power 2x. So this can be written as 2 to the power n, x to the power n, e to the power x into e to the power x. And we are supposed to show that this is fx only, is less than equal to 2 to the power n, n to the power n, e to the power n, e to the power x. So on comparing, this would cancel out, 2n cancels out. Now we know that x is greater than equal to n. And I have taught you in the class as well that exponential power always outweighs the power function. I'm repeating it again. The exponential power always outweighs the power function. And since x is greater than n, so the denominator, so in both these things, I'll mark with green. So in both these things, the denominator would outweigh the numerator. And since x is greater than n, this denominator would be higher value. And so this condition is satisfied. Okay, I hope this was clear. Okay, I'll just take a 1-minute break. Okay, now using mean value theorem, prove the inequality Ex is greater than equal to 1 plus x for all x belonging to this. Now the function would be Ex minus x minus 1 is greater than equal to 0, and this function is continuous and differentiable. So Ex is continuous differentiable, x is continuous differentiable, 1 is continuous and differentiable since it is a constant only. So a composite function would be continuous and differentiable throughout the interval. Okay, now suppose if you're talking about x greater than equal to 0, then there would exist some a which belongs to the interval 0 to x. So it is a positive number which lies between the interval 0 and x, such that, so this is the mean value theorem only, f dash a equals to e of a. So the derivative of ex is, okay, it would be e of a, and e of, so we have f dash b minus f dash a upon x minus upon b minus a, where the limits are 0 and x. So you should not confuse this. Okay, so the limits are 0 and x, so minus e to the power 0 upon x minus 0. So we have this as e to the power x minus 1 upon x. So this is e to the power a. And since a is positive, and since EA is greater than 1, so any power to the exponential is greater than 1, we have Ex minus 1 by x is greater than 1. So Ex minus 1 is greater than x, Ex is greater than x plus 1. So we have this condition. And similarly, for any x less than 0, there exists b in the interval x to 0, such that f dash b equals to e of b, which is equals to e of 0 minus e of x upon 0 minus x. And this would be 1 minus e to the power minus e to the power x upon minus x. E to the power, this is plus x only. Okay, I'll write it again. So f dash b becomes one minus e to the power x upon minus x. And since b lies between x and 0, so b is negative, so it would be 1 upon 2 by something positive. So this would be always less than 1. So this thing would be always less than 1. So 1 minus ex should be less than minus x, and 1 plus x should be less than ex. So we have found the same thing again. And you can use any other, so since it is mentioned you are supposed to use it, you can use it, or else also you can take log and then show that this condition would be always, you can prove this inequality as well. Okay, now moving to the B part. The time in minutes t required for a rat to run through a maze depends on the number of trials n that the rat has practiced. How does the change in n impact change in t? So they have asked you to find t dash n with respect to n only. So this would be first function, derivative of first function 3 into second function minus derivative of second function, this is 1 into 3n plus 15 upon n plus 1 whole square. So this is 3n plus 3 minus 3n minus 15 upon n plus 1 square. So 3 and 3 cancels out. So this is minus 12 upon n plus 1 square. How does the change in n impact the change in t? So if n increases, this term would fall. If n increase, the new denominator would rise and the whole term is falling. So what we can say is, the interpretation would be, if the number of trials are increasing, it would take less time for the rat to complete the maze. Okay. Now, does there appear to be a limiting time in which the rat can complete the race? So limit as n approaches infinity, tn. So this would be limit n approaches infinity, 3n plus 15, n plus 1, taking n in common. This would be 3 plus 15 by n upon 1 plus 1 by n. So limit n approaches infinity. This will approach towards 0, this will approach towards 0. So the whole limit will approach towards 3. So it is expected that in 3 minutes the rat would be able to complete the maze. How many trials are required so that the rat is able to finish the maze in under 5 minutes? So we need to see the number of trials such that n plus 1, this should be completed in less than 5 minutes. This is the time taken. This should be less than equal to 5. So 3n plus 15 should be less than equals to 5n plus 5. So 10 finish the maze in under 5 minutes. So n should be greater than equal to 5 for the rat to complete the maze in under 5 minutes. So if he tries it for more than 5 times, he would be able to complete the race in under 5 minutes. Okay, now moving on to the next part. National income in two economies, X and Y, is growing exponentially at 100 into Rx and 100 into Ry percentage respectively, compounded continuously, where Rx is greater than Ry. So suppose there are two countries, X and Y, and the growth in X is occurring at a faster rate as compared to the growth in, so the rate of growth of national income is higher in country X. In year 0, national income was N0x in economy X and N0y in economy Y. If N0x is less than N0y, at what time will the national income become equal in both countries? First, look at this thing. We know Rx is greater than Ry. And if it was given that NOx is greater than N0y, then at no possible time it can happen that the national income would become equal, because this will keep on growing and this will keep on growing at a faster rate. So there won't be any convergence. But they have mentioned that currently the GDP of the country is low, but it is growing at a faster rate. So you will study solo model in the future, you will get to know about this. So what we have is, currently the growth rate, so the present value, so at time t, this would be the value of the country's GDP, and similarly this would be the value, this is the base, and then the exponential growth rate e to the power r by t. So in the question they are asking, at what time will the national income become equal in both the economies? So this should be equals to this. Now to solve this, take log on both sides. for this and this, so this would become log n x naught plus r x t should be equals to log n y naught plus r y t. So you will have rx minus ry into t equals to log n y naught minus log n x naught. So t would be log n y naught minus log n x naught upon rx minus ry. So at this time period, you will have both the national income converging to each other. Okay, so we are left. We'll do till question 3 only. So there are total of 6 questions. So we'll do till question 3 only. And I'll do the rest of the 3 questions in the other video. Okay. This Newton's formula. Okay, but I'll do this okay, I'll do the D part first, then C. An investment project incurs an initial loss of C naught. So initially you are having a loss of C naught. Thereafter it does not incur any losses and the sum of later profits is greater than the initial loss. So after that, so the net present value of an investment is C naught plus A1 upon 1 plus R plus A2 upon 1 plus R square. So these are the discount factors till suppose a n minus 1 1 plus r to the power n minus 1, then a n 1 plus r to the power n. Show that the positive project has a unique positive internal rate of return. Okay, now suppose when r is close to 0, when limit NPV when r is close to 0, so this would be limit of C naught plus A1 upon 1 plus A2 upon 1 plus till AN upon 1. So this condition is given to us that the sum of later profits is greater than the initial loss. So this particular thing is coming out to be greater than 0. So we have f of 0 is coming out to be positive. And when limit NPV when r approaches infinity, so this would be C naught, this 1 plus r, and if the numerator is very high, so this would be so the denominator would be infinity, so this whole term would be 0. So a1 divided by infinity would be 0, this would be 0, every other thing would be 0. So the limit NPV as r approaches infinity is C naught, which is less than 0. So we know that, okay, I'm just looking for some space. Okay, so we know that when interest rate is 0, discount factor is 0, the project is giving you a positive NPV, and when r approaches infinity, it is giving you a value less than 0. So there might exist one or more than one interest rate such that, so before that you need to tell what is internal rate of return. So it is the rate of return at which the net present value of a project is 0. Now the intermediate value theorem states that if suppose we are talking any interest rate 0 to infinity, at 0 it is coming out to be positive, at r it is coming out to be, at infinity is coming out to be negative. So there would exist at least one interest rate at which the NPV would be 0. But we are supposed to tell that there is a unique positive internal rate of return. So for the NPV, if you will have, okay, so we need to show that there exists a common NPV. unique NPV. So if you will differentiate this with respect to R, this would be 0 and U dash is 0, V 1 plus R minus V dash 1 plus R derivative is 1 into A times upon 1 plus R square. Then for this, U dash is 0, V minus V dash 2 times 1 plus R into A2 upon 1 plus R to the power 4. So it would be 3. So this is also negative. This is positive. This is positive. This is positive A1. And similarly, you will see the rest of the terms are all negative. So the slope is negative throughout. So what we had is at 0. So when interest rate was 0 and infinity, the value was positive and it is falling and it is coming out to be negative when R is very high. So there would exist a unique interest rate only because this is falling for all R greater than 0. So R would be interest rate is greater than 0 only. So it is falling for all R. So there would be a unique internal rate of return that would exist. Okay, this is getting very, very tiring. I'll just try to complete the last part as well. Okay. I'll take okay, I'll do this only. Use Newton's binomial formula to find the approximate value of under root 217, taking the degree of approximation as 2. Also find the upper bound on the absolute error. Now they have asked us to take a degree. Need to find the approximation with degree 2. 217 can be written as 225 minus 8 to the power half. And this can be written as into 1 minus 8 upon. So these are some of the tricks or manipulation that you are supposed to do. Now we have this, and 225 to the power half is nothing but 15. So this would be 15 into 1 minus 8 by 225 to the power half. Now Newton's binomial formula states 1 plus x to the power m is equals to 1 plus x plus x squared, where m is this power, so m is half, and x, so 1 plus x, so x is coming out to be, so we are transforming this thing, we have transformed this in such a manner that it could be written in the form of 1 plus x to the power m. So x is minus 8 by 225. Now solving this, so 15 is common in all of them. So on solving this, we'll have, looking for space. Okay, so root 217 would be approximately equals to 15. 1 plus, this would be m into x only, and this would be m into m minus 1 upon 2 factorial into x square. You can substitute the value of m, so this would be somewhat equal to 15. 1 plus m was half, x is minus 8 by 225, plus half into half minus half by 2 into x square minus 8 by 225 whole square. And so you can solve this value. You can use the calculator to solve this. You will get the approximate value of this. Okay, now you're supposed to find the also find the upper bound on the absolute error. So since it's the we were supposed to find taking the degree of approximation as 2, so the for the error we will see for the third degree x3 1 plus c to the power m minus 3. So mc3 would be half into half minus 1 into half minus 2 upon 3 factorial x cube so this is the value of the remainder 225 x cube would be minus 8 by 225 and where we take value of c which lies between the value of c would lie between x and 0. Since x is negative in this case, so value of c would lie between x and 0. So this would be the cube 1 plus c m minus 3. So half into half minus 1 is half into minus 1 minus half into half minus 2 is minus 3 by 2. This cancels out, so 3 by 8. Okay, so this would be 3 by 8. Okay, you can solve this. So m minus 3 would be half minus 3. So half minus 3 is half minus, so minus 5 by 2. So whatever the value of the remainder would be, okay, so this is what the value of the remainder is coming out to be when c lies in the interval x to 0 where x is minus 8 by 225 and 0. Since it was coming out to be negative sign, and now so 1 plus c 0 point, so this is coming out to be something less than 1. 1 plus c would be less than 1 and to the power something, so it is coming out to be less than 1. So if we take c equals to 0, that would give you the maximum possible remainder value, and for any c between this, the remainder value would be less than when c takes a value 0. So the maximum upper bound you can find when you substitute the value here with 0. Okay, so I'll stop here. We are left with 3 more questions: question 4, question 5 and question 6. We'll be doing these questions in the next video. So far, because this also got very tiring, so we'll discuss this in the next video. Okay, thank you.